Okay, so now we're looking at whether or not something is polar or non-polar. So polarity is caused by different atoms having different numbers of protons. If you have more protons, more pluses, you're going to be more strongly attracted to the negatives or the electrons. So with water, we sketched this out in your little quick quiz. We took a look at water, and water has oxygen, which has 6 protons, and hydrogen, which has 1 proton each. So the oxygens will have a stronger pull on the shared electrons. So one thing you might see is that, well, when we sketched it out, we drew the 2 hydrogens next to each other. You could also two-dimensionally draw it like this, and that would be equally valid. It would look something like that right there. It'd be straight across. The big problem with that is when you have this three-dimensionally, and if we were in class, you would have one of these to mess around with. I instead switched out a carbon in right here because a carbon has extra electrons. So these are going to represent these 2 pairs of electrons that we had in there. Okay, so what happens is electrons, since they repel from each other, they want to get as far away from each other as possible. So if this was two-dimensional, 90 degrees is as far away from each other as you can possibly get. But when you have three-dimensional, the farthest you can get away from each other is going to be 120 degrees. The big overall thing to do is memorize the fact that water is going to be polar. Okay. The next one, nice and easy, hydrogen fluoride. Except I got it switched around a little bit. Hydrogen fluoride, hydrogen here at the fluorine over here. The fluorine has more protons than the hydrogen does, so the fluorine will have a stronger pull on the shared electrons. It'll be slightly negative. The hydrogen will be slightly positive. Oxygen, nice and easy. It has an equal pull. It's linear, equal, symmetrical. They have the same 2 things. They have the same pull on the shared electrons. So this is going to be nonpolar. Likewise with carbon dioxide, even though we would have polarity here and polarity here, much like with forces as we talked about earlier, equal and opposite forces are going to cancel out. So they'll cancel out linear and symmetrical right there.